Okay, everybody, our next speaker is Kent Nebergall. Kent's been involved with the Mars Society since 2004. He's currently the chairman of our steering committee, and he's been out to the MDRS for a couple of tours as well. He's a business analyst with MacroInvent, and his talk today is Solar System Mini Settlements 2060.
All right, thank you very much. This opening graphic is a shuttle era version of what we'll be discussing today. The idea was that if you take all the hydrogen and oxygen out of a fuel tank for a large vehicle like this, then it can be used as a habitat. And Starship has a similar advantage. Bottom line here is exploration requires ships, but settlement requires ports. So we're going to get into how can Starship be adapted to a port and not simply a ship. This is my dashboard essentially of the state of the art as far as space settlement goes. We finally cracked this end with Starship with affordable launch and large vehicle launch. We're starting on this part of it, but we are kind of hitting a wall when it comes to space junk. And then there's other issues, of course, across the board that are further down the schema. What we're going to address is going to take a lot of these areas and address them. Won't necessarily solve all the problems, but at least it'll put it pretty much clearly in the sites here. So one issue with Starship is this orbital refueling. If it's 1 month of launch windows every 26 months and you want to send 1,000 Starships per window to Mars, then you need 5,000 tanker flights to fuel all this up. This makes you a huge target as far as Casimir syndrome, as far as space debris and so forth. So to get around that issue, that's one solution we need. Here's another issue that most people don't think about is the fact that this is an Earth to Mars launch window, 6 months flying out, 500 days, 6 months back. This is Mars to Earth. So all the reds are this Mars to Earth. So you can't have the same ship in 2 places at once. It cannot simultaneously be going from Earth to Mars and Mars to Earth. So you need 2 completely separate fleets if you stick to the home and transfer orbits. So the good news is that during these windows, you can do domestic transportation or lunar transportation or satellite launch or whatever. But the bad news is that during these windows, all of those ships are in deep space. They are not of value to the local economies. So you would need a domestic Mars fleet as well as a domestic Earth fleet. And I don't think this is really being addressed in addition to the 1,000, so the 1,000 Starship fleet is actually more like 3,000 or 4,000 when you come down the line further out in time. And then in addition to that, you have things like cycler fleets, which could go from Earth to Mars and then continue on into the asteroid belt with shorter flight times here, but then longer return times. But that would allow us to start industrializing the asteroid belt beyond Mars with the same vehicles that we're using for Mars transport. So in a nutshell, this issue with refueling on orbit, space debris, the departure Starship train with the large fleets and so forth. And then another factor is psychological adjustment. If you have this many people going, somebody's going to be a little freaked out once they get out in deep space and everything starts getting real. So we want to have sort of a halfway house essentially for people to adjust to that psychological stress, where if they can't handle it, they can always just come straight home. So when we take the orbital refueling issue, this is sort of a first principles design. We cluster the ships on orbit, and this is a short animation. So basically what's going to happen is it's going to strip away the hangars, and you'll see in this slowly spinning ring, we have the tankers on one side and the starships on the other. This allows the propellant to settle. We have this debris shield ring, which is several meters thick and can be made of ice. And then since this ring is here anyway, there's no reason we can't modify Starship and make a centrifugal habitat set out of essentially a derivative of Starship, which we're going to call Star Car, since they are stuck together like cars on a rail line. So this is getting a little more detailed with the central core, the various connecting elements and so forth, and then the hangars open on the side, and then the tracks for the Star Car. And then, so back to our logistics problem, we fill up 48 tankers on orbit in one of these stations, so the propellant is safe. We can then launch another 48 starships, refuel them rapidly, produce enough fuel to at least get them to a Lagrange point, have another station like this, a little Lagrange point, and we can stack these as noted off the central axle. Then we can have as many of these in this station as we want. This is at a gravity level exactly halfway between Earth and Mars, so they can adjust to the lower gravity and so forth. If there's any health issues, any psychological issues, anything where they just don't like the food, whatever, they have a sort of mini settlement here. And this, if you were not necessarily going all the way to Mars, if you just wanted it as a tourist destination to learn to be like a space colonist, this is exactly the destination you would go to, and then you could come back to Earth relatively quickly. But for the ones going on to Mars, you can launch them, if you load this entirely with regular starships, that's 96 per ring. So 10 of these and you've got the entire fleet of approximately 1,000 ships. Getting onto the hangar design now, we're going to get into that a little bit. Why did I make them this big? Starship 2.0, Elon Musk has said, is going to be double the diameter, but not much longer. So I wanted the hangars to be big enough that we could fit Starship 2.0 as well as have a system that's interchangeable with the current design. And then you can also break these down into smaller grids and so forth. So these can be used, mix and match. You could have several of these, one of these, whatever. Or you could have just 3 of these with no barriers between. So going back to the hangars, the idea here is this ring does not spin very quickly, if at all. You spin it to settle the tanks, but that's it. The rest of the time, it's relatively inert. So while the ships are coming into dock, you could grab them with a robot arm, similar to what was done with the original Dragon capsules of the ISS, where you'd reach out with an arm and berth it into a port on the side. You would set them in here, and then this is the idea here, is that you'd have a rotating carousel where each one could be docked in on the end. This is out of the bomb bay of a modern bomber, but the idea would be to use this central axle like that, and then your docking ports are off here, and then you would have essentially a rotating dock here that would unlock, reseal every time it was rotated into a new position. But the advantage of this is you can access all the starships without having to undock or redock or whatever the situation, the system. If one of them gets stuck, you just rotate past it and keep going. So about that star car concept, one moment. The idea here is that you would launch something built on the same assembly lines as the starships, except you would get rid of the central engines. You would leave the vacuum-rated engines because you're not going to land. You don't need fins, you don't need a heat shield or any of that stuff, similar to the lunar module. You make a removable end here that has the header tank and the RCS system. And this essentially becomes its own little space tug. It's your aerodynamic fairing on launch, and then it would help you with guidance on the way to and from the destination, whether it's a ring or just being used independently. Now, when this thing settles into place, you can get rid of both of these rings, and you've got this central unit. Like I said, this bulkhead's been removed. You can move those, and then remove the doors to these bulkheads, and then you've got a straight path through the thing, just like you would have through rail cars on a subway. And then to scale, this is basically 3 stories tall. This is a 3D model with everything taken off, and then these rails essentially, and then the docking ports on the side. This is, again, sort of a simplified model, of course. And then if you actually want just a big ring here for this front part, you could always run the path down around and then through the middle for the other parts. So this was the original conceptual diagram. It's 300 meters across. You could put these with a straight docking adapter for conventional use in like the ISS in microgravity, or you could put an angled adapter between here for this sort of thing. The capacity of a 20 star car ring is 40,000 cubic meters. That's enough for 160 people, including the space needed to grow food for 160 people, which is close to the Dunbar number, or basically the number that organizations use, where everybody knows everybody. You could do that per ring. And then this is a cross section with the hangar, the central pier, and then this ring arrangement, and then the ability to dock things onto the other end. So the star cars, this is to scale, and then this is more of a notional concept. You would have this heavy debris shield, which in deep space, you would have a cosmic ray shield here of up to, this is actually shown at close to 10 meters, but this is a, you would wrap this shield around to block cosmic rays or debris or whatever, or both. And then you have 7 slots, like I said. The beauty of this is that you could have a magnetic levitation system like this, which would also help block radiation from solar flares in and of itself. Then we have another thing called a fiber optic light rail. Yes, that's a pun. The idea here is you would direct light from mirrors and fiber optics and so forth into this ring here and this track. And this is passively sends daylight directly in via fiber optics. So you can grow the plants and so forth by concentrating light into this rail, sending it through a small hot port, and then distributing it back through the rest of the station. So you're able to get power, and while that light is concentrated, you could also probably you would draw electrical power and heat off of that concentrated port. Basically, somewhere in here you'd have a secondary port for that. Then the beauty of this system is that since these are Hallbeck arrays, because we want all the magnetic field aimed in one direction, you don't have magnetic interference in the crew section inside. The other beauty of this is that if you have a block of ice or whatever here, not only does a cosmic ray or whatever coming through here, let's say this is a 1 meter shield, it's more than a 1 meter shield because the magnetic field will influence charge of the particles coming in. So this 1 meter shield effectively is a 1.5 or 2 meter, depending on the energy of the incoming particle and the level of the magnetic field. In fact, if there was a solar storm, you could always just crank up the magnetic field a lot higher. If you take this same habitat and you put it on Stickney crater on Phobos, this is at 2 scale, so you're actually below the rim of the crater. So you are blocked by Phobos from below and Mars from above in terms of cosmic rays and so forth. You would still have to deal with solar flares, but like we said, that's much easier. And then if you scale this up to a 1G settlement, it still fits below the rim. Escape velocity for Mars is only, or I'm sorry, for Phobos is only 25 miles an hour. So you could actually just go into a star car on the outside of this that's still got the fuel tanks and so forth and release it, and you are going 4 times the speed of departure velocity without kicking up any dust, which is more of a critical issue with these asteroids. So you could have a similar thing with a big steel plate essentially for landing as well, since you're essentially docking with an asteroid in those cases. And that way you can keep things from getting too dusty in this environment. So just to go over some of the basics here, these are the basic components of a free station. It's extremely simple to scale up the star car from Starship. These frameworks are very basic. The shielding blankets are basically just bags of stay chute material, similar to Bigelow habitat, except with ice or water in between. Solar arrays we've been doing forever. Light gathering arrays basically just be fiber optic channels. The centrifuge rings are, again, relatively simple. This would be sort of a made in space arrangement. Those could be made with asteroid materials down the road. Mag rail is based on existing technology, and the hangar doors are fairly basic as well. And the other thing is you can use these on, if you transport the materials to a surface habitat on the moon or Mars, then you're able to do that as well. The other beauty of this is it's scalable. So it's anything from 10 to 10,000 people without changing the hardware. And then it's a pay-as-you-go system. So we can learn and build over time and refine the system instead of trying to build $1 trillion habitat and hoping for the best. So this is a much more doable system for space settlement than a lot of the systems that have been proposed before. And since I mentioned it on the abstracts, skyhooks, you could hang a Phobos tether off. This is a common concept, although I wouldn't want it to go so low that it could interfere with the Starlink constellation. And then you use these magnetic shields for local access. And then if you have a cycler, of course, you could release off the cycler using a tether to get to Mars as well. So any questions?
Do we have any questions? Feel free to
I see a
unmute.
hand.
Feel free to unmute and ask your question.
Yeah, I'm trying to hit ask to unmute on the echo. There you are. Okay, hello.
Could you please go back to the slide with the skyhook? Yeah, that one. I had missed that. My internet lagged out. Thank you.
No, okay. All right, any other questions?
Yes, I have a question.
Okay. Go ahead.
My question is it possible to build a ring around a planet in the far future that could support um, a similar a, a similar idea as yours?
Um, well, you want to start small, but yes, it is possible. You would this is meant to be things that we could do in our lifetime, but you could put a ring around an asteroid with this technology. I would suggest actually doing it for small asteroids. There's also, if you are interested in that topic, there's been a lot written about that in relation to space elevators, and I believe Isaac Arthur has an interesting video on YouTube. Um, so look up his name, Isaac Arthur, and there's an idea for you make essentially a tube in orbit that is not quite in orbit, because the stuff in the tube is actually has enough rotational value to stay in orbit. It's a fascinating concept, but that's not the topic of this paper. But yes, it is an interesting area of study. In the comments, Scott is saying, I missed the beginning. Do you intend these rings to be permanent settlements or way stations? Yes. They are a way station that can be used in the long run towards the end of building, eventually adapting them into a permanent station. So the initial idea is you'd have one in low Earth orbit with a shield from space debris, and then a high Lagrange point where you would have that more for cosmic ray shielding because you're in deep space, but you could make these into cyclers or asteroid habitats or whatever. Then the nice thing about it being modular is that you can always tear these things apart and make whatever you want, like Legos. But in the long run, if you have a ring like that, there's no reason you can't make a pressurized version of this ring. I'm sorry, going wrong way. This ring, you could make the whole thing into one big pressurized structure. Land these rings on Mars? No, but the components you could. So this hangar, you could make a vertical version of this with exactly the same hardware and use it to protect the hangar from dust, the ships from dust and so forth, and do maintenance on the surface of the moon or Mars. And then the star cars, of course, you could use in a centrifugal habitat on the surface of Mars if you wanted to simulate Earth gravity as a banked track model.
In the near term, how do you get the propellant to the ring?
Basically, you'd have the tankers go up, and the beauty of a tanker is if you can do tanker to tanker transfers, then you can stage them. So you could have like a set of tankers in low Earth orbit that are fully fueled. The tanker sends itself partially; it uses part of its fuel to get to the Lagrange point. It could transfer the rest of its fuel and go forth. And then you could also do the same from a lunar base as well to transfer oxygen from a polar region or whatever.
Jeff Fitzsimmons says, I like the modular approach. It seems to be a theme for the conference. Did you do a rough cost estimate for the structure?
Not as such, no. This is more notional. So the idea is to keep the basics of it as simple as possible, but the beauty of this is that structure is so simple that if you then decide to go start a business where you're capturing old spent rocket stages and recycling the metal from them, and this would be a perfect opportunity for Made in Space or some of these companies to build out more sophisticated structures using, you could solve two problems at once by cleaning up the space debris and using it as a resource, and then eventually going on to nickel iron asteroids and so forth and picking up from there.
Any other questions folks have? Feel free to unmute yourself and ask. Another question, how would you make the design comfortable for untrained colonists?
That's part of the beauty of that secondary of having this this intermediate ring is first you're in low Earth orbit. You could always go to an observation deck on the inside and go back and look at the home planet in microgravity. So you get the novelty of that, but you're also at roughly halfway between Earth and Mars gravity. When you get out to here, then you're eating, your diet would probably be down to vegetables, small fruits, fish, and probably chicken and eggs, but you wouldn't necessarily have a lot of red meat in a situation like that because there's just not enough room to grow it. So you're starting it's a slow adaptation where the gravity levels, everything else is slowly incrementing towards the Martian environment. It's not a lot of shock of being in a microgravity capsule or small vehicle for 6 months and then being on a completely alien world for 500 days. How big are the inflatables compared to the Bigelow? They are the modules are based on Starship. So this whole module, this is a Starship diameter, and there's a Starship 2 diameter, so 18 meters. So it's meant to be on this scale. So if I go back here, this is a Starship right here with the wings folded. So it's scaled up from that, but it's all based on that concept.
So that question was, how about using inflatables or expandables like Bigelow 330 instead of launch vehicles like Starship? I'm going to read the questions, Kent, because it's for the recording, you know?
Okay, sorry. Yeah. We are using the technology for this barrier, here would be identical to Bigelow, except it's flat. It's just basically filled with water, but it's the same material. So it is sort of that, but not quite. We don't want it too flexible because we don't want the ring to oscillate.
Would there be any reason not to spin it and create artificial gravity? Any reason not to?
Yeah, in fact, that's the beauty of this, is it's optional. So like those gray sections in this diagram would be presumably not spinning, but you could de-spin the whole thing if you wanted. But it's nice to have the option when it comes to mitigating the health effects of microgravity, to have the ability to spin up to that gravity level, or to make a bigger ring with exactly the same components. The only thing you have to swap out is the middle parts. And you have to swap out the middle parts anyway, because this track is longer than this track. So these interfaces between the modules are all different. But the star cars themselves are the same. Mm-hmm. And you could also hang, like here, you could hang a microgravity factory off the bottom of this and not spin it.
Okay. Is it possible to use these for outer planetary transport and beyond?
It's designed to go out to the asteroid field without modification, just bigger solar panels and bigger light collectors. Once you have fusion power, or if you have a really good low enriched uranium reactor, then you could do it out to the outer solar system, no problem.
Any other questions, folks? We've still got about 5 minutes.
Are you talking about a question?
Go ahead.
So are you talking about the possibility of having this actually be a spacecraft if it had a propulsion system?
Yeah, actually, I was just about to mention, you could hang, if you hung tankers off the bottom of this, a tanker is basically just, in this case, it would be vacuum Raptor engines and tanks. So, and you could refuel it from another tanker. So you could hang a bunch of these off of this pier down here and apply some delta V on the central axis. I think it would be more of a station, because you would, obviously there's a lot of mass here to move, but you could, the beauty of it is if you have a cycler orbit, you could build this over time in a cycler orbit, or launch like all the materials and then build it en route to Mars or whatever, from the materials that you brought with you. So you'd have a fleet that would build this sort of thing. And then next time you came around to Earth, then you could add more to it. But, or you could build it en route to the asteroid field and then just plug that stick there essentially on top of an asteroid, spin it in place, and then you've got your surface habitat. But you're basically, you have a gravity field as well.
Are there any similar models being constructed on Earth now?
Not that I'm aware of.
Yeah, me neither. May I ask, what is the chances for this great design to succeed in orbit and to maintain it in orbit?
Well, this is just me and my kitchen, so it's not, a fully funded project. However, in terms of taking all the problems of space settlement and flipping them back on their head so that we have a mitigation strategy for it, it is probably the most simple, low-tech solution to that problem that I can think of.
Any other questions, folks? We've got about 4 minutes left.
Yeah, are these designs written up anywhere that we can access them?
Not yet. This was, I generally pour my life into these presentations right up until the last minute. However, these, I'm sure Bob will be happy to know I will write these up as papers, because I think this and the project I'm proposing tomorrow, I think, are some of my most beautiful works. So I actually want to get those written down and put them the Mars Society website and possibly submitted professionally.
Mars PD, I should write some articles for that. I'm sure
Yeah.
Bruce is on the call. He'd like that. Oh, he was on the call.
Okay.
Any other last questions, folks? Yeah, Anara says Asgardia.com might be interested in your work too.
That's an interesting project, and I'll just leave it at that.
Yeah, same here. Are you planning to propose these to a few commercial space companies?
If anybody from SpaceX happens to see this on YouTube, I would be happy to talk to you. My email is in the thing, but yeah, I mean, it's like I said, I'll write it up and I'll see what happens. But if you go back through the Mars Society channel, I have a lot of designs over the years that I think have a lot of potential, and they do improve over the years. I think last year's was a masterpiece, and I think these two from this year are going to be really good. The one I'm doing tomorrow is paraterraforming, which is a little more long term, but it's probably the most elegant thing I've ever built. So
cool.
I'm looking forward to that.
Yeah, as someone who's edited all your talks over the years, I really enjoy your work.
Thank you. And thank you for whoever else complimented me in the stream, by the way.
Yeah, just some comments. Well, I guess one person's asking, when will you plan to execute this great design? I think you answered that already. SpaceX has your number.
Mm-hmm. Yeah, pretty much.
Okay.
It's funny, one of the talks I did was called Accelerate Like Elon, and Next Big Future picked up on it, and suddenly most of my talks get like 130 or 160 views. That one got 14,000 views. So that was kind of a shock. So you never know where these talks end up.
We're doing our best to get them out there for posterity. So
I appreciate that.
Yeah. Do you have any other? Yeah, he's got a lot. The question is, does he have any other designs? Yes. Go on our YouTube channel.
Just
Nebergall.
put my name, comma Mars, and then you'll see a bunch. Although one somebody typoed, and so I'm eternally known as Kurt Nebergall for one of them. So.
Oh, is that on the YouTube channel? I think I fixed that a couple.
Yeah, there somebody typed that. Yeah, I was looking for one of my videos. Like, where is it? And it's like, oh,
yeah, that was my fault. Right. I'm sorry.
I
fixed that though.
Okay.
I fixed that.
Okay. Oh, you did. Okay.
Yeah.
Okay.
Yeah.
Consistent with Blue Origin's mission. I think that's actually probably the biggest selling feature. If I went to Elon Musk and was proposing this, is it would basically. Jeff Bezos wants to do the old L5 Society concept. This would totally eat his sack lunch because it would basically do everything that the old L5 Society does, but it would do it with Starship, but it would do it a lot cheaper and faster. So either one of them, frankly, could make use of this. But I have a feeling Elon would do it out of spite.
What design do you like the best?
Between what and what, I guess. Between
what was your favorite
SpaceX
thing? What was your favorite thing to design and then look back on later?
The one I did last year for the space habitat, the 1,000-person settlement. Mm-hmm. I consider that to be my masterpiece because that I solved every problem. I deliberately set the bar as high as possible, and then I solved all the problems, including the economic problems of Mars settlement.
I've got
yeah.
I've got the book right here.
Yeah, I've got the book. Yeah, I've got it back here too somewhere.
He's in here, everyone. So
yeah, I'm chapter 7. So yeah, I'll probably put a poster of Bob handing that book to Elon on my wall one of these days, along with all the.
Yeah, that was an awesome moment for everybody.
Ray Bradbury stuff for us.
Yeah.
Mm-hmm. but I
Well-
was in the top 10 at least. I didn't get the top 5, but at least I got the top 10.
Well,
So tells you how good
that's
the
saying
drawings
something out
were.
of over 100 entries, top 10. I mean, that's pretty amazing.
Mhm.
Alrighty,
Mhm.
thanks a lot, Kent. And thanks
you.
everybody. I hope you enjoy the conference. We'll see you for the next talk.
Yeah, if you like this, you'll love tomorrow's. So just leave it at that. It's beautiful. So
Cool.
thank you. Take
Thanks
care.
a lot.